Magnetism. Making magnetism using electric current is called electromagnetism. Here this is a simple experiment. You are just passing a DC voltage through the coil, and the coil is wounded to a nail, and the nail acts as a magnet. Why it does that? So any moving electric charge creates a magnetic field around it. So when I pass an electric current through a loop of wire, it it creates a magnetic field around it. So the field strength you can increase by piling up a lot of loops, making a nail to behave as a magnet. So when I pass DC voltage through the coil, the electric current is moving from the positive terminal of the battery to the negative terminal of the battery through the coil. A magnetic field is produced around the coil, so the coil behaves as an electromagnet. An ordinary nail does not behave as a magnet. So when I bring a nail near to the south pole of the electromagnet, the nail gets polarized. So the nail is now magnetized, and it behaves like a magnet. So when I bring a pepper pin near the nail, it is attracted towards the nail. This is due to magnetic force of attraction. Let's say I just change the direction of the current. What happens is the poles of the electromagnet reverses. You might think that a nail inserted into the coil will be repelled now by the electromagnet, but that is not true. It is once again attracted into the coil. This is because the nail ion atoms reoriented to line up whatever pole the electromagnet presents. What if I pass an AC voltage through the coil? Does the nail acts like a magnet again? No. This is because you can see that the DC source, the direction of the current never changes, but in an AC source the direction of the current changes periodically. So when I bring a nail near the electromagnet, the poles keep changing constantly, and the nail will not get any magnetic properties. Electromagnetic induction. So producing an electric current using a moving magnet, this is called electromagnetic induction. So I have a coil of wire. I am bringing in a magnet which has two poles, north and south. So when I want to measure the current, I just connect the coil across a meter. When I want to measure the current, this meter can be an ammeter. This was proved by Faraday. So he has a law: when a magnet is moved into a coil of wire, changing the magnetic field through the coil, a voltage will be generated in the coil. So here in the animation you can see that the magnet is moving inside the coil. So the faster the magnet moves, the faster it keeps changing direction. Hence the frequency of the signal will change according to how much faster you move the magnet. So as I mentioned, this is an ammeter. The ammeter can measure the current.